us try another examples of integrating by partial fractions. This is the functions needs to be integrated. The function here seems to be quite complicated to be resolved directly. And then we will use the partial fraction to solve it. First, we need to determine the constant a, b, and c here. So, these functions will be equivalent to this, where the factors here will carry one term each. Set the constant number as a, b, and c here, as we still do not know what is the value here. To solve this, the a here is to be multiplied with the other two factors from the other partial fractions. Same goes to the b to be multiplied with the other two factors, and the c to be multiplied with the other two factors. This is so that all of a, b, c here can be placed under the same fractions. Next, you expand the fractions. Multiply a into the functions. Group them in accordance to x squared, x, and the constants. And this will make comparison with the original equations here. From here, you know that a plus b plus c is equals to 2. A plus 4b minus c is actually equals to -9. 6a minus 3b plus 2c is equals to 35. Beware of the positive and negative. As here is negative value, and here is also negative value. With that, 6a plus 3b plus 2c will be equals to 35. You will have 3 equations here and 3 unknown. Solve the 3 equations using simultaneous solutions. You will get a equals to 4, b equals to -3, c equals to 1. Substitute the respective value into the equation here, and you know that integrations of this will be equals to this as a functions of the partial fractions. With that, you are able to integrate every single term by using the long. Remember to put the c at the end of the integrations. Next, use the principles of log. The 4 here can be bring forward as a power of the factor here. Same goes to the 3 here to become power of 3. And the relationship between the long plus and minus will determine it whether it is in the multiplications or in divisions. The c will remain. This will give you the final solutions. Let us try this example. You have 2 functions here, which seems to be quite complicated, and their relationship is in the form of fraction. With that, you know that you're going to use partial fractions to solve these integrations. Next, you need to decide the factors. What you see here is the degree are the same. That means these functions can actually be divided by the factors below. So let us do some direct divisions. The x squared plus 1 is actually equals to x squared plus 0x plus 1. The bottom part of the fractions will be the one to be divided. The first term, x squared, is 1-to-1 conditions. Therefore, you will set this as 1. When this function is to be multiplied with 1, you will get this. Minus this term with this, you will get 3x minus 1, which is 0x minus 3. Minus will give you plus. Plus 1 minus 2, it will give you negative 1. Therefore, these functions can be rewritten in the form of 1 plus what is left over out of the calculation just now. Then you determine the factors. Because there are 2 factors there, this can be separated into 2 partial fractions in terms of a and b. Multiply the factors of the other partial fractions. You will get this. Expand it and group them in terms of the x and the constant number. This will be made comparison with the factors here. You know that a plus b will be equals to 3 and a plus 2b will be equals to 1, since the negative value here is the same. You have 2 unknowns and 2 equations. Solve them simultaneously. You get a equals to 5, b equals to negative 2. With that, integrating these equations is actually can be rewritten in the form of this as calculated from the direct divisions here. And expansions of this, it will give you this after you decided the simultaneous solutions. Eventually, you will see the transformations of the functions into 3 terms, which is more easily being integrated. Integrate each term of them. 1 will become x, the second term it will become ln, and the third term will also become the ln, and there will be a constant c. The 5 here will be brought into the power. The 2 here will also become the power. And the relationship between the 2 ln is divisions. That means this can be divided by this. Rewrite the equations, you get the final answer.